Hey guys, this will be video 6 for the how to restore a vintage Gibson SG. This is the 69, and primarily what I'm going to be talking about in this video is moving in the direction of fitting the neck and how to go about cutting all these, making all those cuts right there. So that's going to be the bulk of this video, but I just want to do a little bit of a flyby and also put that up there so I don't forget. I want to do some tap tone analysis of what happened after I beefed that up. And so the brief recap is this was originally the old, thought I had a pointer, I'll just use my pencil. This originally had the deep V, or whatever they call it, the V cut. So it was weird how it was radiused. It was straight on the back, and then it was extremely thin out here, but I don't think they realized how thin it was because when they built this guitar, they were doing their sanding work back here, but then when it came to the back here, rather than allowing that to just stay straight with the back, it actually got pitched a little bit in order to probably they were trying to achieve some sort of smoother transition from the neck into the body, probably to make it feel like it was real thin, and they didn't realize just how hyper thin they were getting right there, and that's what contributed to a lot of the breaks. When it would break, it would do a catastrophic tear out down here. But now I don't know the dimension. I'll get to it later on. I'm just going to guess. It's probably about, I shouldn't be doing that. Let me give you my dimension. But this is not, this is irrelevant, quite frankly. It's actually a quarter. Okay, so it's 6 millimeter. Right there. I don't know how far back in there that will reach. No, it won't reach all the way, but we'll reach as deep as we can. I'm getting a reading about 10 millimeter. So it's actually a little bit thicker than that in the very back here. What does that contribute to? Tone and strength, or strength and tone. So we got a massive amount of wood back in the little body here. And let me get these rattlies screwed down so they don't rattle, because I'm going to do some tap tone analysis here in a minute. But you're going to see it made such an incredible difference in the strength and the tone of the guitar just by that little bit of additional material that's in there. And as I had clarified in the past videos, this fillet that I glued in the bottom is quarter sewn. And I kept forgetting to mention that even these fillets that I'm glued in up here, or epoxied in, they're rift sewn, but you could call them basically quarter/rift sewn. But in other words, the annular rings go this way, so they're substantially stronger when you install wood on the quarter. So let me knock something out briefly. In video 5A, I was so wound up with the whole explanation of the pitch, and this is really important because I overspoke, and I made a statement of what this dimension is back here from the top of the guitar to the bottom of the D string. I made a statement in video 5A at the 28 minute and 40 second mark. I said that was 14 millimeter. That's incorrect. The studs average roughly 14 millimeter in most of the guitars that I build, like the Explorer replicas. But at this location right here, the bottom of the D string is 19 millimeter. It's considerably taller. So that was a pretty serious oversight. But I still think that even if someone was actually building a guitar and they started working with a bamboo skewer and all that stuff, they would realize that there's no way that 14 millimeter is going to work out here under the saddle. I got confused, and I was thinking about the top of the studs on the 58 Explorer replicas that I built. But since this neck is roughly coming out of the body roughly an eighth of an inch higher, it just raises everything up. So apologies for that oversight, but I think it's one of those things that as you started working with your own project, you'd realize that I had made a mistake. Okay, so back to this guitar. Let's do some tap tone analysis, which is, I believe I did this in the second video. I'm almost certain I did. where I pulled the guitar out of the box and I was, doing all the analysis of what does it sound like. So I'm going to stop talking and just, you want to hold the body like that right there. And then let's do some tap tone analysis. And if you have earbuds in, I turn the volume down. This won't be too terribly loud, and I'm not going to be tapping nearly as hard as it sounds like I'm tapping. But I'm not going to be very gentle with it either. But I'll do the perimeter tapping, and then we'll go up the middle. And then I want you to listen once I get up here. If you didn't catch that foreshadowing, it's 100% improvement. So let's do some tap tone. Hear how thuddy it gets right there? It's because that's like 1/4 of an inch thick. So you remember how thuddy it was out there. Now let's go down the middle. It's hard, I can barely get in between that wall. Okay, so we got the guitar back. And that's, I can't even begin to explain or express how much difference that's going to have on the tone of the guitar. And I would start talking about all the other guitars and the original designs and stuff. And it might have just been that this one particular guitar was a mistake when they produced it. So I'm not going to throw them under the bus, but this is far superior than what they originally had. Okay, so now let's start talking about fitment. So we know we're in good shape right here. And where's my, I had some, oh, here we go. I have some eraser shields. But this was some of my reasoning as to, as far as locating the center lines and verifying how I wanted this tenon to feel when it goes into the body. And it would be awesome if it slides about like that, but is rather stiff, of course. But I got a feeling the way I've machined it so far, it's probably going to be a little bit tighter than that. But I used this right here to assess the center line of this jig, or this little temporary tenon, to make certain that I was getting really close to the center of the bridge down here, because this is really important, primarily because I don't have any material that I can either shape a little more on this side than on that side, or on this side rather than that side, in order to get it true. I'm having to work from this original location right here. So there's a very strong possibility, because I'd mentioned in the very early videos, I don't want to relocate this bridge at all. I want to be working off that bridge location, because that's going to determine where the current pickguard is located, where the current pickups are located, or the original. So I got to work within this point right, the centering of that point right there. And then if I have to exaggerate and do this or do this in order to make it work, then I have no choice. And that's what I meant by I'm going to be fitting this neck to this body. But if I were building this guitar from scratch, I would have this close to, it'd be about 2 3/16 of an inch wide right here. And after my neck goes in, it would get about a 1/64 of an inch shaved off on both sides. Well, that's a perfect world where you're working with jigs. But since I don't know this guitar body, I had to build this neck as close to this dimension as I could get it, so that I didn't get complacent in my dimensions. So this, in other words, this is the most narrow neck I've ever built. and I was almost spooked because it's about a 16th of an inch more narrow than I like to build. But there's ways that I can correct that throughout doing all the fret work and all that jazz, so it'll be fine. But in addition, I'm even going with a little bit wider nut out here at 1 and 11/16. This guitar probably had like a 1 and 9/16 inch nut on it, or at a minimum, it might have been 1 and 5/8 inch nut. But based on this taper that I see going on right here, this guitar had an extremely narrow nut width. And when you make that change up at the actual nut location, if you widen just a little bit up here, that trapezoidal taper, that path, it carries all the way up here, so much so that if you really want to know the truth, the neck, this heel needs to be about a 16th of an inch wider, but we just don't have it because we're working with our original dimensions. But there are ways that I can get around that. I'm gonna stop talking about that because it'll get too hypothetical. But I'm not there yet because I know that there's going to be some issues that I have to deal with to get that to where it looks really good. It's unnoticeable, but primarily from a player standpoint, when you play the guitar, everything feels true and in line. So how I did that was based on that dimension there, plus the two eraser shields on either side is a real nice snug fit. Then I basically just took the two eraser shields, put them on this, and then I took my calipers and I just calipered down, tighten up my caliper. Could care less what that dimension is, but I did have to look at it, and it's right at 33 millimeter. Again, it should have been about closer to 35 millimeter, or at least 34. So then all you do now is you find the difference, you split the difference, and you just you will start working off the center line of your neck because that's where your truss rod is going to be. You want to keep that in the center. So everything about this job is now the magic number is 16 and a half millimeter off the center. So I'm going over and I'm making a mark on that side and I'm making a mark on that side. And the way I cut this, I set the table saw blade up to be, oh, that's awesome. I set the fence up like this right here. Okay, and a lot of guys have asked me, how do you cut your tenon? How do you cut your tenon? It's the easiest thing you've ever done. If you can cut a square board, then you can install in that guitar neck into a body, and basically that was and so you make a vertical line right here, and you're working with a very thin mechanical pencil, and you have to be thinking along the lines of which side of the mark am I cutting on. And then if you're the type of person you get confused easily, then make an X on the side where you want the blade. Or if you're listening to talk radio, turn it off probably unless it's therapeutic for you. But just make certain that you're following which side of the blade are you going to be cutting on. Am I going to be am I going to push the blade up to this location, the fence up to that location? Well, now I'm going to be cutting on that side of the blade. And then I could flip it over and do the same thing, but we all know that when the fence gets closer to the blade, there's very little platform under there. So because of the insert, so what I did, or what I always do, is work off the inside of the blade. I got all the table saw deck right here. My fence is nice and true, and then this is probably the most important thing you'll ever do on your table saw. Raise the blade all the way up as high as it'll go, and then take this find this dimension right here where the actual blade is coming through, and then back up about a 16th of an inch. And then once you find that blade, you back up about a 16th of an inch, take a Sharpie and draw a Sharpie line on your deck so that when you're cutting, you actually can look down at the deck of your saw, and you'll see that Sharpie mark coming into view, and you'll know when to stop. And that will allow you to get dangerously close. Well, we'll say dangerously close on this side, because if you come through this one, well, that's your heel. You just lost your heel. So you got to make certain that, if anything, I like to get as close as I can, because the closer I get, the cleaner and truer my tenon is by using the table saw. But having that mark, that line on my deck, allows me to, I'm not really even watching the blade. I'm not watching the blade up here at all. I'm looking over here, and I'm making certain that Sharpie mark comes up here, and I stop just a little bit before, then I pull back, assess it, and if it looks like I could go another 1/16 or an eighth of an inch, then I go ahead and go a little bit farther. But then up here, it wouldn't be that big of a deal if you cut through this one, but that's extremely poor craftsmanship. So it wouldn't matter, because, well, I said it doesn't matter, because of that right there. See, there's your blade. So you're not going to get anywhere near your heel on this particular cut, but it sure would be sloppy work to come up here and cut up into the neck. You don't, I know you guys aren't going to do that type of stuff. Read between the lines. So know where the most dangerous point is, and the most dangerous cut would be this cut right here, knowing when to stop that one. Okay, but I like the idea of just setting that depth right there, and I'm cutting on the outside of the line, and then the way I'm verifying this, well, with that whole roughly 33 millimeter right there. Right now, I got a feeling this tenon is going to be a perfect fit, or it's going to be snug. So let me go ahead and I may do some of this work on camera, but I may just pause and do the work freehand, because I don't want to risk getting into that. I can't. Let me pause, because I cannot risk getting into this heel, even with just my pull saw, because what I'm about to do is take my pull saw and start cleaning up that cut, so that little piece can fall out. And then the reason I can't risk screwing this up on camera, or not on camera, is because that's pretty much the minimum thickness of the board I have. Sometimes, you're working with a little bit of excess, and you have some leadway there, but this one was machined fairly close. So let me pause briefly, get the table under control, and think about what I need to talk about, because I may come back and go, oh, by the way, I forgot to mention this. So let me pause and get the table under control, and then we'll go from there. Okay, the longer I stayed paused, the more I realized there was to talk about. You got to start from a scale, and we already know that the scale of this guitar is 24.625. So based on that, you need to go to your fret scale calculator. I use TundraMan. Just do a Google search for TundraMan fret scale calculator, and use his program, and just type in, whatever scale you need, and you have to determine what the distance is from the beginning of the fretboard to the 19th fret, if that's what you're working with. And we're working with the 19th fret location. Okay, so if we're working with this 19th fret location right here, so 19, 20, 21, 22, that'll let you know how much of this neck is going to be getting cut off. So don't let that throw you, because we're clearly working from the 19th fret location. So from the beginning of the fretboard, which is this location right here, okay, see where I'm going with this? You got your nice flat surface right here, and then whatever nut, if you were doing a Floyd Rose, then I'm not going to move this fretboard down, but if you were doing like a Floyd Rose where it's the really wide nut, just know that you'll have to extend your neck to receive the really wide nut. Okay, so everything about your engineering, that 19th, that location right there, defines everything, because that is the 19th fret. We know that if you're truly following this series. So that's the guitar right there, correct? So if we know that that's a given, that's a constant that cannot change, because if this changes, then this changes out here, and we don't want to do that. And actually we can't. So we're building this neck from this 19th fret location right here, which is that line right there. And what is that magic number? Looking on my chart here, from the nut to the 19th is 416.512 millimeter. Even though I typically work a lot in SAE, being in the States, when I'm laying out my fret scale, because I actually cut my own fretboards from time to time, I do every bit of my layout in metric. It's so much easier to find the middle of 77 millimeter than it is whatever that number may be. If it's like some sort of 32nd or 64th or something like that, or if it's some sort of weird SAE number, it's so much easier to lay out and cut everything in metric. So based on that, 416.512, I know that, and it's true, I know that, and usually what I do is I'll start at 200 is my zero. So I'll just be going up to 616. And I'm just guessing at it. But if you look at the 616.5, that's roughly the 19th fret location. I didn't even look at it, so I might have been off a little bit. But we know that we've got a 24.625 inch lower here. If we weren't going to work with this, then you definitely need to write on here, probably even in ink, up in this location right here, or in this location, exactly what this scale is, so that you might know what you're working with later on. So once we have that, we're ready to start making all these cuts. And since we had created this little initial piece to work with right here, if you remember, I went ahead and cut this on a parallel 2.5 degree back here. So I know that's 2.5 degrees, and it's plenty tall enough, right, for that. And this is the easiest thing in the world. I've never done it this way. Well, not recently. I usually just do this on my miter saw. I'll do the pencil marks. I'll just do the pencil mark tick right here and the pencil mark tick right there. And then I'll go over to my miter saw and I'll set my miter saw on 2.5 degrees. And I'll make this cut down, kind of a cowboy cut. Then I'll flip this over, change the miter saw over to the right side 2.5 degrees, pull down and make that cut. Then I'll put this on the miter saw, take it back to 0, but lean the miter saw over 2.5 degrees and make that cut. So every bit of it is done with the miter saw where I'm zipping. The only thing you need to be extremely careful with is the miter saw blade as it's coming out right here in the back. Sometimes it can chip this out really bad right here or right here. So sometimes take a little bit of jet glue, maybe jet glue that to strengthen it up a little bit so you don't have tear out. But I changed gears on this one and I did it a little bit differently, very different. I did every bit of it by hand with my fret saw so that I could show you guys there at home that you don't even need a miter saw. You can do every bit of this with just a nice clean poplar. Okay, so if we know that's our target, you don't want this to go across here because you need clearance for the blade. So back off a little bit. Set that on the table. I'm not going to do this. Put a block right here and put a C-clamp on it and let the C-clamp lean over on the side. Put a block right here, put a C-clamp right here, and in other words, let the two C-clamps fold out and act as little legs, and they'll actually lift it up a little bit. Now, simply, I'll have to do it with this quick grip just so I can keep it under control. Now, your piece that you cut on your miter saw, or maybe you didn't have a miter saw, whatever. If you don't have a miter saw, you need to invest one. But you simply slide that up there And then this is where you would now take your quick grips and just clamp that, and take your ridgeback fret saw. And this is a little bit strange. Typically I'm used to pull saws. This is a push cut saw. Let me just put it down there. I'm not gonna, it might have, yeah. But you see, and you're just going down to that target right there. If you go beyond it a little bit, it's not the end of the world, but it's better to not go all the way. So basically, just every bit of this is done in an old-fashioned sense by using this guide. And all you're doing is simply, like I said, like herding cats again. All you're doing with this one, you're just simply holding, and you're just pushing, but you are reaching over and holding that blade nice and square up against that flat right there to make that cut. Flip it over, flip this over, make that cut, and then the way I did this, I went ahead and just put this up here like this, and I just connected the two lines. Sorry for the chaos. It's just I don't have room to really show this because I got that crap over there. So now, you're making that cut right there. So it's like dovetail work. It's very simple, and the mahogany, so easy to cut. Cuts like cotton candy or like balsa. So what would happen next? I can't use this saw anymore because it has the ridge back on it, and it would stop me. So as I'm getting ready to relieve all these little pieces, okay, I'm sorry, now I'm getting ahead of myself. After I make those identifying cuts right there, I'm through with this area up here. Now it's time to go to the table saw and do all that table saw work that I was talking about earlier, where you're, lining everything up, and just make that cut and flip it over and make that cut. Okay, see how nice that is? And then what you need to do here, when you're getting ready to relieve this, if it's obvious, if you just put that up there and you look at it and you see visually, there's no way that's going to fit. Well, then bring your fence in, just a very small amount. Bring your fence in just a very small amount and make that cut again. And maybe just kind of kiss cut it on the front so that you can just visually assess everything and see how close you're getting. It's really one of those things where you can kind of, you don't even have to measure this. I didn't measure the the table saw at all. I just followed those pencil lines and made certain that I was cutting on the correct side of the pencil line. And I'm just kind of moving the fence until it fits. And then if it's a little bit loose, then I need to back up. And if I screwed up, it's not the end of the world. You put a shim in there, a little nice maple shim. But if you do have to do shim work, make certain that you glue the shim to your tenon on your neck. Well, or vice versa. If you wanted to put the shim in the bottom or just the shim on the side, that's okay. But we really want to try to not do that if we can from a craftsman standpoint. So, but I'd rather have a guitar with a shim in it that was correct than one that was loose and full of glue. So let me try to get the table cleaned up a little bit. Okay, so I know I kind of blew through that a little bit, but for the most part, all you're doing is just following the pencil line, and it's actually very simple. I do love using the table saw to do that initial straight line work because even though I use like contractor grade DeWalt, it's not a very high quality saw, but I've got that baby set up so true and so precise, and I've got a brand new blade on it. It just cuts with so much or so little effort. Okay, so what I'm going to do now is pause, and hopefully it won't be too far in the video, and I'm going to go ahead and set up to relieve the rest of these little pieces with my little pull saw here, and then immediately we're going to have a tenon. And see, I haven't cut this depth cut yet. See, I've still got to cut off about over 1/4 of an inch here to lower it down. Well, This will show you exactly where we're going to be cutting. Well, close enough. Okay, so that area will be getting cut off last. This is going to be the next cut that I make right here in order to start creating that tenon. And this is what I was talking about in one of the past videos. I'm fairly confident with all of my engineering. I probably could go straight to the finish line with whatever depth that is, but I'm not. I made that mark, but I'm going to be about a 32nd of an inch high, maybe even a 16th of an inch high, just to be safe. And then I'm going to come in here and fit it and do the whole pitch assessment again, not on camera because I've done it too much in the past several videos. But I'm going to verify my pitch assessment, and then what I'm going to do is just continue going back to my table saw, sliding the fence over ever so slightly and making this cut right here, you know, as the blade is coming across right here, following that Sharpie mark that I made on the table saw deck to make certain that my blade doesn't go. Even though I know the blade, yeah, for certain, this is where you got to be really careful and really follow that mark right there, because as you're pushing up, you won't realize that your saw, even though your saw blade might only be coming back here, you won't realize that the saw blade is actually already entered up into the side of the neck, and that's game over. It's not. I mean, this mahogany is really easy to feather little pieces in like that, and you would be surprised what you could get away with. But we don't want to do stuff like that unless we just have to. But if that happens, don't get discouraged and throw your job away, because if anything, it's going to be on the, well, I shouldn't say that. I started saying it's on the travel side, so it doesn't matter. It's not nearly as bad if it's on the unseen side, but we don't want to build the cars that way. So, all right, so sorry for just the chaos, but it's one of those things where you wouldn't have a clue what I'm talking about unless you had already spent a lot of time behind a table saw. But if you have spent a lot of time behind a table saw, you know, building birdhouses, if you want to know the truth, you can do this. Okay, so let me pause, get organized, and then we'll go from there. I'll jump back in just for a brief moment because this little piece is about to fall out, but you can see the cut there that I made with my little pull saw. And basically all you're doing is just kind of, I had the clamping on the edge of the table here, and when I was making this cut, I was just keeping it true. And then, but I was looking down to make certain that I didn't get into that heel. So basically, I like the pull saw because obviously you're pulling, and that's really dangerous. I've cut my thumb before doing that stuff. So there you have it. And then at this point, don't get discouraged if you've got a little bit of a lip right there. But make certain that you've got a really nice, clean, sharp chisel that you can now just kind of go across that a little bit if it needs it. But you know, obviously, don't get into the heel. Got to stay away from that heel, and you can see there's a little bit of a material in there. And if you guys are on a video like this, you know the importance of this being stationary, clamped down, and you have full control of the job as you're working this down. So that's the only cut I've made. And then the next cut will be this relief here. And the way I'll make this cut will be the same. I will be doing this right here, basically. Should be able to do a little bit of it. I'm making certain that blade stays flat. And even though it's a pull saw, you know, I just kind of go back and forth. But by keeping pressure on that blade, I'm guaranteeing that I'm staying flat on that tenon surface. Because what we're cutting out up here is this top part. Okay, so let me pause the camera, pull it over to the edge of the table, so I can clamp it and keep control of it, and then I'll be right back. One thing I had forgotten to mention, before you do all this relief cut, and obviously that's what it's going to look like when it drops. It's where your table saw blade ended, obviously, and you can see where I started testing my table saw cut, where I was a little bit wide, and then I moved it in. So that was my test cut right there when I was doing the very first cut. But the reason I'm showing this is you want to make certain that if these two pieces are over here and you have a mistake, let's say you screwed something up really bad right here and you got to make a repair. Well, if you have done a really good job of labeling before you made your cuts, I call this neck B. It's because it's the second neck. I've got an AA and an AB, and then I've got a BB and a BB. So this neck is kind of noted as BB. And obviously when I was doing all my layout marks, here's the B for the bass side, and it's the B neck. T for the treble side, and it's the B neck. And I even have an arrow pointing in that direction. It's kind of obvious because of the cut. But if I had a problem down here and I had to make a repair, well, guess what piece of material laying in my arsenal would be the absolute invisible repair? Even if I lost that whole corner and I had to repair that whole corner, I would make the cut from that little location right there, and then that's where I would use the tight bond, because the tight bond would be virtually invisible when you make that repair right there. Or let's say it tore up right there, well, then you could use that location right there. So make certain that you locate these, and at this point, even though the problem hasn't happened yet, I go ahead and tape these together right now. And I have a special little box that is in my chest over here, where I have these in the event I have a misfortune. Now I can go to that location later on and get that item. Okay, so let's see how it fits. Moment of truth. Okay, now that's pretty tight. With a neck that fragile, don't get all excited and start pushing on that. You literally could split this body in half. So at this point, I need to make the determination. Okay, I've got a real snug fit. Actually, too snug. But let's do some assessment and see what we might be working with here. And I'm just gonna sight down it visually. Oh wow, that's pretty cool. Right now, and it might just be that the neck is not in true, but by just doing that little bit of sight work right there, I'm sighting down the center of the neck, and I'm looking between these two studs to see if I'm pretty much a guitar. You know, is it on the center line? And right now, it's actually pointing down a little bit, but you know, don't fret if it's off. And then see back here, yeah, it won't go in back here, and that's because I haven't even done any shape work on that. But that's fairly close right there. I would say it's close enough that I wouldn't recommend going back to the table saw. But don't be afraid to go back to the table saw at this point, because it would just be a matter of just doing a little bit of trimming. Especially if you put this in here and you sighted down it and you saw that the whole neck needed to move up in that direction. And if it's that tight and it needed to move in that direction, then go over to your table saw and move your fence in, just not that much, but exaggerating, and then take off that amount, and then you'll have that circle. That's where you'll have to take your chisel and clean that off, and then slide it up in there. Right now, it's going to be it won't be nearly as snug as it is right here, but it will start loosening up a little bit enough that now you can slide it all the way up in there and clock. I call it clocking, where it actually clocks with that location right there. And once you start clocking, where I'm going with this is, and again, I don't want to push this because I don't want to split anything. But once I start getting this heel very close to this location right here, I can begin to assess how accurate my pitch is. The two pitches, are they truly parallel? And as I start cutting the length of this tenon off and I move closer and closer and closer, I get it to the point where I'm like a 1/16 of an inch, and then maybe even to the point where, oh, I lost the compass. Oh, there it is. Maybe to where I'm sliding a piece of acrylic in here on this side, and I'm sliding it over here on this side, sliding it on the bottom, and I'm verifying are these three sides coming together very consistently, because if they're not, however, based on the center line rules, because I could shorten this side here in order to allow that neck to start moving in that direction if I need to, or I can shave off a little bit of, not off the body, but off of my neck. I can shave off a little bit of material here in order to allow that head to move to the base side. You catch my drift? So right now, and then as you get closer and closer and closer as you're coming in, then you start making the assessment of, okay, you're actually down to the point to where you're sliding eraser shields in between it, and you're asking yourself, is the eraser shield tight on this side, but it's a perfect fit, but it's loose over here? Well, then that lets me know that I need to shave off a little bit of material here, and I'll cover that in a future video, how to do that. And you have to also be careful about you're having to watch that bottom as well, because it may be fine up here, but what's happening is you're binding down here at the bottom or something like that. So let me pause and go make a table saw cut along this bottom, and I might do a little bit of sanding and shaping just to see if I can get it to slide up in there a little bit smoother, but not at the expense of doing any damage. So let me pause. Okay, I forgot to mention, I've covered this numerous times, but basically all I did was measured the tenon depth on that, then transferred that pencil line, and as you can see, I'm about a 1/16 of an inch wider. When I was over there, I was kind of in the dark, and I almost screwed up, but it doesn't matter because all that's going to get cut off anyway. All the more reason to build your neck about a 1/2 inch too long. But as you can see, that I'm actually almost a 1/16 of an inch less than the actual target. So what got me in trouble right there. Another thing you can verify to make certain that your table saw is running true is just look at the thickness here and the thickness there and verify that it looks good, because if it's off a little bit, then you'll need to adjust your table saw. Looks pretty good. So on that note, I will go ahead and pull saw this, flat. Even though I know it's, let me think, do I want to do this? Yeah, I've got to do this because I want to go in. So let me pause, clamp this, saw this off, because this is going to be the most dangerous cut as far as making certain I don't hit both sides. And I probably will even get down to the point to where all I do is just go into it with a chisel and just right there at the very end, just snap it loose, rather than running the risk of trying to saw all the way up to that, because that's the finished guitar, and we've got to protect that. Okay, so let me pause, clean that up, go from there. It's about to fall out. Close enough that it can be snapped, but when you are at this point even though you might be up here sawing like this as you're sawing through, when you truly get to the end, make certain that you're pulling and just being real gentle with it. And then if it doesn't look, if you feel like the teeth are already already there, then what may be going on is you may need to go down a little bit deeper right here. First thing you do, you don't need that anymore. Well, you could, this would be a good way to check out what's going on with your cuts. 6 millimeter, yeah. You should be able to see it, like if it's funky right here, then it's funky right there, and it's not going to go in properly. So you got to get that stuff under control. Again, see, I've still got another, a minimum of a 1/16 of an inch to take off, but at least right now, I've got a very nice, clean, hand-cut tenon chisel, and I got to be really careful with this chisel. I got this thing razor sharp. But anyway, we'll get there in a minute because I've still got some more work to do. But I did not do any sort of sanding on this a little while ago where it was really tight, because I wanted to see, maybe, it might have been that it had a little bit of a flare to it. And if I had have started sanding on it, well, once I got this material relieved right here, oh, sorry. Crap. I put that tape up there so I could actually go ahead and preserve that piece. So this is the BB neck. Now let's see see if there are any changes to the fitment. I hope there's not any changes. I hope it actually is just as snug as it was before, because if that's the case, that will let me know that all of my cuts were very true. If all of a sudden this thing just fell in, that would scare me. It's still snug. I'll try to do as much of this on camera as I can, but it's just get a feel for it. It's pretty good. I'll push it just a little bit, but not much. This is what I was talking about, where you can start coming in and taking measurements. And I don't mean with an actual measuring device. I just mean something like this right here. Wow, what are the odds of that? What are the odds of that? Let's see if we can get lucky. No, it's no big deal. If it fit, it fit. If not, that's no big deal. It may mean that the neck is in there on a little bit of a pitch, but I don't know why I'm showing this, because I don't start taking those measurements until I'm down to like within a 1/16 of an inch. But with this right here, I begin to see the actual job come together, and I can just see that, yeah, let me stand up so I can look at it. What I'm doing, I'm just sighting down it. Again, it's really tight, way too tight to be messing around with. So let's take it out and maybe assess it there in the back. Another way, see how I just took the neck, flip it upside down. What that tells you right there is most likely everything about your work is very, very S4S, very, very true. So I've got the neck in upside down, and you can even look at this. You can start doing things like, I can't tell where I am. You can start measuring again, I'm jumping the gun here, but you could start measuring things like this right here, verifying they're identical. So that lets me know that everything about the tenon is perfectly true with the guitar. If I can go in upside down, then I know that I've got a good, I'm doing nice machine work. And all I got to do now, I guess we'll just go ahead and do this. It's going to take a second. Since it did seem to fit just a little bit better, all I want to do right now is just get it in flat so I can sight line down it. Yeah, it's actually, the center line of the neck is pointing down just a little bit. So what that means is I start doing, since I'm really snug right here, what I may start doing, if I'm going to remove any material, I'm going to be removing material. Now, I need to be careful saying this. Stay true. Keep everything nice and square because this may be flaring a little bit, but if I had a noticeable difference where it was really pointing down like 1/8 of an inch low, I'm going to go ahead and make the anticipation that I need to start removing a little bit of material on this side more, or it may just be that when I was doing my table saw cut, the blade might have traveled a little bit. And see, that's nice. It's nice, and all the more reason to work with an S4S. See, you would not have wanted to do your taper. By not having your taper yet, you can use that as a means by which to verify everything. Ah, look at that. See, I'm a little bit loose right there. So what does that tell you? That allowed the neck to kind of travel down a little bit. So if anything, probably what I need to do is possibly, it's not, I'm looking at it, it's not even a 64th. So this is just building a guitar. You've got to start making the determination of, okay, well, do I come up in here and take a little bit more material out of this area right here? Or do I'm sorry, I should have been on that side. Since it was a little bit low right there, if I took off a little bit more material, now if I took off material right there, it would allow the neck to move this way. If anything, I need to be making fitment by, yeah, that would work. By taking a little bit of material right there would allow that to come over where it probably is supposed to be. Because we've done too good of a job with this initial straight line fitment to start doing any sort of offset tapering. We don't want to do that if we don't have to. In other words, right now, if this is hitting a little bit low, let's just try to move the whole neck in that direction. A little, and I'm talking 64ths of an inch right now. Okay, let me check the time. 53 minutes. That's a good place to end the video. Let me just look at the table. I can't think of anything to talk about because when it comes to fitment, this is true. This is true. The next thing I will be doing is going over to the table to my miter saw and cutting this in on a 2.5 degree angle. And I know that I'll be cutting a considerable amount of it off, but don't go there just yet. Don't get overzealous. Just kind of ease your way into this, and then what I'll do is I'll just go take I'll clip off about 1/8 of an inch up here on a 2.5 degree, because as I begin to fit this in, I do want to make contact. Where in the world? Oh, it's right there. I do want to make contact with that back, because out of this whole guitar, that's the only point I really trust. And if I can get my tenon loosened up a little bit, and if you want to know the truth, that's an excellent fit right there, especially if you're epoxying in. If you're doing tight bond, I'd say it needs to be a little bit tighter than that, but just a little. But I really trust that back wall back there as far as helping me get that point under control. So I'm going to cut that on a 2.5 degree slope and then start easing a little bit of the material off and working my way back. And I'll be clocking back there with about an 1/8 inch gap up here. That's irrelevant right now because I'm not ready to fit these three sides. Right now, I'm only trying to verify my yaw axis, which is this axis right here. Okay, so I appreciate you guys dropping in, and hopefully it was a good video for you. And it's very simple. Every bit of this could be done with a little $30 saw. And if you want to get one of these, I can't think of the name, Philadelphia Luthier Supply. I think they're in Michigan. This is also my Jescar fret saw. Zona, this is a USA 18 teeth per inch. And I want to say this is 230 thousandths point, or maybe 235 thousandths, 0.235. And what is that? Is the fret slot. Perfect for fret slots for doing your fret work. And I get this from the same company where I buy my Jescar frets. So they sell this specifically for doing your fret work. And then obviously you just saw we used it to actually fit a neck, or the initial fitment anyway. All right, appreciate you guys dropping in. I'll see you in the next video.